This section is all about writing equations and solving them based on word problems. So we're going to take what we know about equations, we're going to now have word problems with them. So we're going to look at a few examples of just converting words to algebraic expressions or algebraic equations. For example, it says write an equation using one variable, do not solve. The rate at which Bryce travels a distance of 156 miles in 3 hours. So this should bring back to you, remember, distance equals rate times time. And so Bryce travels a distance of 156. That equals his rate, which we do not know. So we're going to write it like that, multiplied by his time, which we do know. And of course, you know from algebra, this is not how we typically write that. We're going to write it like this. But you have set up an equation. And so one step equation, very simple to solve, and then you can go on. Sometimes you will see equations that involve geometric shapes. And so, like this one, a room has a length 3 feet longer than its width and a perimeter of 78 feet. So, a couple things that should stand out: the word perimeter. We know perimeter is 2 times width plus 2 times length. You'll notice that they have the 2 times width here, but instead of a length, they have width plus 3 because it's 3 feet longer. And then its perimeter is 78 feet. And so once again, we have set up an equation that we can easily solve. You may also have equations that involve percentages or percentage off or percent interest, like this one. The original cost of a dress for 29.99 at 40% off. Well, if you're looking at the original price, they used point 0.6 here because they took 40% off. So the original price with 40% off, you just paid 60% of the original price to get the current price. And that's how they set this particular one up. So you need to bring back all the types of equations, whether it be from geometry or algebra 1, that you have worked with in the past. Now, as we solve equations, there's specific steps that we're looking for. The first step is to read the problem. And so you want to make sure that you are reading it carefully. And as you are reading it, you want to make sure you're taking note of specific words that they're using, key phrases, type of problem, and you want to represent them algebraically. By that, we're setting up X's for things that we don't know or some type of variable. And we want to set it up with an algebraic equation that we can solve. The next thing we're going to do is we're going to plan. We got to make a plan. You want to organize that information either into a diagram or a table. You may have to sketch something. You may have to create a table before you can actually set it up algebraically. Then we are going to solve our equation. We have written an equation. We are now ready to use what we know about solving that equation so that we can get to a specific answer for this problem that we've been given. And then the last thing you want to do is you want to check that. Relate that solution back to your original problem. And you want to answer the questions by looking at your answer and saying, is this reasonable? We don't want to have a negative time. Negative time is not reasonable. We don't want to have a speed for a vehicle that is hundreds of miles an hour. That's not reasonable. And so we want to make sure that when we solve these problems, we are going back and saying, does this make sense? So let's look at some types of problems we might run into. The first type of problem we're going to talk about is consecutive integers. So consecutive means in order. And then integers, obviously, we just talked about that in the first section here. Integers are whole numbers and their opposites. And so if they have a consecutive integer, they have started with 1, and they're going from one to the other by adding 1. What I mean by that is if you start with 3, the next integer consecutively would be 4, and then 5. And you can see that we added 1 and we added 2. You could also hear the terms even or odd integers. Again, let's say they said odd integers and we started with 3. Well, the next odd integer is going to be 5, and then the next odd integer is going to be 7. Again, you can see that we went by twos. And so when you don't know these integers, you're going to set them up with n's, n plus 1, n plus 2, or x's, and then n plus 2, n plus 4 if they're even or odd. So this one says the sum of three consecutive integers is 135. What are the integers? Some keywords here. Sum, we're going to be adding. Consecutive integers, that's going to tell us that we are using 1, 2, and 3 to add for the next integer. We do have three of them. And so as we set this problem up, we are going to let x be that first integer. Well, if x is the first integer, we go from that number to the next one. We just go up by 1 to get to the next number. And the third number will be going up by 2. And so remember, we highlighted that keyword sum. Well, sum means we're going to add them all up. So we're going to say x plus our x plus 1 plus our x plus 2. And we know that it is 135. Remember, is represents equals in these equations, 135. And now we have a pretty basic equation that we can solve. We're going to combine our like terms. We have three x's there. Our like numbers 1 and 2, and 135. We're going to subtract that 3 from both sides. 3x equals 132. And then we are going to divide by that 3. Now, keep in mind, when you divide, you have just solved for x. So when we divide 132 by 3, we are going to get that x equals 44. But they wanted all of the integers. You are not done with that problem. The answer to all of the integers is 44, 45, and 46. Now, is that reasonable? Well, if you add 44, 45, and 46, you get 135. So yes, that is reasonable. Another type of problem you may run into are supplement problems. So supplement of an angle measuring a specific degree. Now, again, this is pulling back from geometry. Supplemental angles add up to 180. So if I'm finding a supplement, I'm going to subtract from 180. Complementary angles add up to 90 complements. And so if I'm finding a complement, I will subtract from 90. And so they will sometimes give you problems that say, find the complement, find the supplement. This example here, two angles are supplementary. The larger angle is 30 degrees more than twice the smaller. So those are important. You're talking about supplementary angles, and they've given us some information about the larger angle. Find the measure of both. So first of all, let's talk about that larger and smaller angle. We're going to assign a value to that smaller angle. They referred back to it, so we want to give it an X. Now, the larger angle is 30 more than twice the smaller. So this is why we set it up twice the smaller plus that 30. Now, since these angles are supplementary, remember they add up to 180. So we're going to take that smaller angle and we are going to add it to the larger angle to get that 180. So that's where we get the x plus the 2x plus 30 equals that 180. And again, pretty simple here. We're going to add our like terms. We are going to subtract that 30 over, and then we are going to divide both sides by that 3. Now, we get 50 degrees for that angle. Again, find the measure of both angles. Make sure you answer the entire problem. If the smaller angle, which is what our x represented, was 50, then our larger angle should be 180 minus 50. So now you have the answer that of both angles. You want to say that your two angles are 50 degrees and 130 degrees. Then you want to ask the question, does this make sense? Does it follow this logic? They add up to 180, we can see that. But is the larger angle twice the smaller plus 30? Well, yes, it is. 50 times 2 plus 30 is 130. The last type of problem we're going to look at are numbers in a given ratio. For example, if they say the ratio between two sides of something or two numbers is 7 to 5, we would just put an x with each of those numbers. 7x and 5x would represent those side links or whatever they're referring to. And then we can use them in whatever equation we need for that specific problem. Look at this example. It says the footprint of the Lincoln Memorial is a rectangle. Determine the memorial's dimensions and area if the perimeter is 620 feet and its length to width ratio is 19 to 12. So some keywords here. It is telling us that it is a rectangle. That is important. And then they gave us the perimeter and the ratio of the sides. So in this particular situation, you may want to draw a picture of that Lincoln Memorial here. And you would want to label it. So you want to say, well, the length to width ratio is 19 by 12. And remember, we're going to use X's there because it's a ratio. And then they use the word perimeter. So once again, we're going to say 2 times the width plus 2 times the length equals its perimeter. And once again, we have a fairly simple equation to solve now that we have set it up. 2 times that 12x plus 2 times that 19x. And then we want to simplify those like terms. We want to add the 24 and the 38, and they were really nice. Divide both sides by 62. We're going to get x equals 10. Now, they want the dimensions. We have solved for x. So pay attention here because in order to get the dimensions, we have to plug x into each of these. So we are going to plug x in 19 times 10. Well, that's 190 feet. Plus 12 times 10, that's 120 feet. Those are the dimensions that we have gotten. And again, is this logical? Does this make sense? Well, that is definitely a 19 to 12 ratio. You can see that. But then you want to go back and say 2 times 190 plus 2 times 120. Does that equal 620? And it does. And so this is a logical answer for this problem.